All right, ladies and gentlemen. So hopefully I can keep this decently brief. But basically, what you're going to do today is we just took a quiz, so we're going to be starting the next section. You're going to watch this video, obviously, and then you're going to do some problems from the book. We'll keep it nice and easy. I think it's only 6 problems. So no work that you need to post, but I would definitely suggest writing the work out on paper anyway. But also, please make sure that if there's anything else you owe me, that this would be the opportunity to do it, because I'm not giving you a ton to do here, and I'm not giving you the hardest problems for sure. Okay? So what the plan is, we're just going to talk a little bit about the thing we looked at yesterday after the quiz. I'll talk a little bit about the steps. I'll show you 3 examples, and that'll be about it. So here we go. All right. So in terms of this, I like the scale idea when we do these types of problems, because it really represents the equal sign really well. The equal sign is basically saying that these two sides are balanced, they're equal. And if we are to take something, for example, from this side, if I take these 4, I'll pick a different color here. If I take these 4 off of this side, the scale becomes imbalanced, right? Because now this side weighs more. So it would go down, now it would go up. All right, so if we're going to do something to one side, we have to do it to the other. And ultimately, we need this balance because we want to find how many is in a bag, one bag, right? Each bag has the same amount. We want to figure out how many is in one bag. So we need to get one bag alone and have it balanced with whatever's left. All right, so whatever we do to one side, we have to do the other. So if we could take away 4, we take away 4. So right here, I'll circle it in blue. This is what we have left in terms of Sour Patch Kids. Loose Sour Patch Kids. All right, let's talk about the bags. If we want to keep it balanced, if we have 2 on one side and 3 on one side, we just take away what they have in common, right? So take away 2. What you have left is a bag on one side, and it's balanced, right? It's going to be balanced with those 5 on the other side, because we took away the 4 candies on both sides, and we took away the 2 bags. Basically what they had in common, look, 4 candies, 2 bags. 4 candies, 2 bags. What was left was the bag equals 5. And we can represent that with an equation, right? So that would be 9 plus 2. I'll use x, you could use b. The scale is the equal sign, and 3x plus 4. And look at what we did. In order to solve this, so now this is what's different. We have variables on both sides. Look at what we would do to solve this. Take away 4 from both sides. Hey, that's exactly what we did right here. We took away 4 from both sides. All right. And then what did we do next? We took away 2 bags. Minus 2, x, take away 2 bags from both sides, all the while keeping everything equal, right? As we take away 4, the scale remains balanced. That's what that equal sign means. As long as we have that equal sign in the middle, we have to keep these sides balanced by doing the same thing to both sides. So we're doing the inverse operation, right? Plus 4, so we minus. Plus 2x, so we minus. And it's 5 equals x. So what does that mean? That means that every one of these bags has 5 candies. So this is the type of problem we're going to look at, where there is a variable on each side. And just like before, if we have numbers on both sides, we can take them away or add based on what the sign is. It's the same thing with the variables or the bags. In a sense, we can take away bags from both sides. We can do the same thing with the x common terms, basically. All right, so here are the steps. Step 1, use the distributive property to remove any grouping symbol. So yeah, if you have distributive property, you probably want to take care of that first. Though oftentimes there's a variable trapped in those parentheses, and so getting them out so we can actually solve for them, it's going to be your best bet. Simplify the expression on each side. Yes, definitely. So once you have distributed, if there is distribution, combine your like terms on each side. So each expression, as in both of them on each side of the equal sign. All right. Collect your like terms. Collect the variable terms on one side of the equation and the constant terms on the other. So then think about what we did here. We got everything with a variable on one side, everything with the numbers on the other. Isolate the variable, check your solution, right? So let's go and follow those steps for this example. Solve this equation. You can see right off the bat, there's a variable on each side, and they are trapped in parentheses. So we're going to have to use step 1. And this here is warning you, saying you don't have to do every step every time. Sometimes you won't have to distribute. In this case, you do. All right, so let's go and do that. Let's go ahead and do step 1, which is distribute. So 3 times everything in the parentheses. So 3 times 3x, 9x. 3 times -4. Same thing. Take the 1/4 times each of those. Now, you can do it in your calculator, but it's also taking it times 1/4 is like dividing by 4. So 32 divided by 4 would be 8. 6 divided by 4. I'm actually not entirely sure what that one is. It is 14. Should have known that. Plus 14. All right, so step 1 was distribution, right? Step 2, simplify the expression on each side. Can we combine 9x and -12? The answer is no. Can we combine 8x and 14? The answer is no. So check that. Collect the variable terms on one side and the constant terms on the other. So that just means, so if you look, you have a kind of, you're looking at like terms, but you need to, look across the equal sign. So the 9x and the 8x are like terms, but we need to collect them on one side. This is where I do the inverse operations. You really could write it as like, I'm going to do the inverse. You have to do the inverse operations either way, but there are different ways to write it. So I'm going to look at 9x and 8x. This 9x is bigger over here, so I'm going to subtract the 8x over here. So I'm going to subtract the smaller number, so we don't have to deal with negatives. It is possible to do it the other way and subtract the 9x, but I like it this way because then 9x minus 8x, 1x. You want to write the 1, you certainly can. So we're collecting all of our x's on one side. I did it based on the fact that the 8 is smaller, so I subtracted. It's positive 8x, do the inverse to get 1x, and then I'm going to do the inverse of -12, or subtracting 12. All right, to then get the 1x over here. This obviously cancels. Then it's equal to 14 plus 12, so 26. That's your answer. X equals 26. I don't necessarily love that 1 there. I think it looks like you still need to do some kind of division, but you're done. So we isolated the variable, got the x's by itself, and then it says the step 5 is check your solution. I didn't mention that step. If you want to, and I might ask you to do this, I'm not going to do it personally here, but you're going to take 26, put it back in for x, both x's, and then just simplify to make sure. All right, I'm only going to do one more example, actually, I think. So here we go. Solve the equation, -2x equals 3x plus 10. First step, is there distribution? I don't see parentheses, so that's going to be a no. It says simplify the expression on each side. This is all by itself, and these two aren't going to combine. They're not like terms. All right, so we're good on that front. Step 3, collect the variables terms on one side. All right, so let's do that then. We need to get all of the x's on one side. I see that there's already a number over here. There's no number here, so let's go ahead and subtract 3x from both sides. It's a positive 3x, so we're going to subtract it. We have to do it to both sides. That inverse operation, and then negative 2x minus 3x would be negative 5x. And then we took the 3x off of this side, and so what's left is 10. Once you have isolated that variable, and then once we have it isolated, we just got to get the x all the way by itself. So this is negative 5 times x. So we have to do the inverse, divide by negative 5. So 10 divided by negative 5 is negative 2. And that's your answer. To check, you just take the x, you plug it back in for x here, simplify, make sure that it is correct. That's the last example I'm going to do. Please come to office hours, or if you do need to meet, we can meet during class time, even though it's asynchronous. But other than that, take care, guys.